Hi everyone, my name is Rishika Agarwala and I am a third year PhD student at University of Virginia. My topic for today is analog frontends. Analog frontends are present around us in almost every day-to-day applications, but they are not so obvious to us because they are smaller in size and very compact. So let me first start by sharing some examples. Smartphones have become an integral part of our life, and smartphones always have analog front ends for talking to various sensors like accelerometers, GPS tracking, and compasses. Similarly, our homes nowadays have a lot of smart technology like smart bulbs for energy saving, temperature tracking for sensing the temperature of a room, and smoke alarms to detect any fire hazard. We also have started using a lot of wearable healthcare devices like Fitbits, smartwatches. These have analog front ends to give us vital physiological data such as ECG, which gives us the heart rate of a person and also blood pressure. Last but not the least, we also have automobiles which have analog front ends present in order to sense the speed or proximity of the vehicle to any other object. Now, let us start with why do we need an analog front end? So the signals coming from a sensor can be present in any form, like sound waves or vibrational signals. Now these type of signals are known as continuous signals, which are also known as analog signals. Now the signals which can be detected by our processor, where our processor is nothing but the brain of our computer, should always be in the form of discrete ones and zeros. This type of signal is known as a digital signal. So what we need is a bridge between a sensor and a processor, which can convert the continuous analog signal into a discrete digital signal. This bridge is known as analog front end. Now, let us first start with a natural example of an analog front end. Our ear. Our ear is something which we use to listen to any of the surrounding sounds. So our ear is nothing but an analog front end given by the nature. So let's say whenever there is a sound wave coming in, our eardrums convert this sound wave into vibration energy. Then our middle ear is used to convert this vibration energy into fluid movement, which is then converted to an electrical signal using our hair cells. Then this electrical signal is processed by our brain to interpret what the incoming sound wave is telling. Now let us jump to the real world of circuits. So this is a block diagram of a very simple analog front end. Now the signal coming from a sensor is always very weak and noisy. By noisy, what we mean is there is some added noise to our signal from the environment near it, near the sensor. So let us first look at the first block in the chain. The first block is the amplifier. The job of an amplifier is to convert this weak signal into a stronger signal, which is known as amplification process, and also at the same time it converts the incoming weak signal, which might be in the form of anything like sound waves, vibration, or any other continuous analog signal form, to a voltage signal form. Now here we can see the output of the amplifier is much stronger, but it is still very noisy. So now what we need is a filter to remove this noise. Why do we want to remove this noise? So any added noise degrades our signal quality, which might affect our performance and at the same time give us untrustworthy, that is false data. So what we have is a filter. What the filter does is it rejects all the noise which is added to our signal and gives us a more clean signal which is ready for digitization. Now what is digitization? As we have seen before, to read the data, to interpret the data coming from this sensor, we need it in the form of a discrete digital signal. So this block, which is known as an analog to digital converter, is used to convert the continuous analog signal to a digital discrete signal in the form of zeros and ones, which can be then post-processed. So that's all that is from my side in regards to analog frontends. Thank you so much for patiently listening to me. If there are any more questions, I have included my contact details in the last slide. Please feel free to contact me. Thank you.